Dr. Andrew Greer is a scientist at Lincoln, working to prolong the useful life of current anthelmintic drenches by targeting only animals losing productivity due to parasitism. This targeted selective treatment will reduce the overall use of drenches and extend their viability.
This project really is about trying to optimise the use of anthelmintics in livestock grazing. The idea really is in terms of trying to prevent or slow down the development of anthelmintic resistance, so providing or leaving some animals untreated so we can provide a population of parasites in refugia. Now these are, by in refugia I mean a population which is not exposed to the treatment and therefore not selected for anthelmintic resistance against the drugs that are used. At the moment we've been using it really in the stud flock, but ultimately we'd like to see it out on farms and seeing people actually take this approach and run with it on their own commercial properties. In terms of the system we have for the sheep, it requires individual identification, largely because of the numbers of animals involved. The practicalities of actually looking at individual animal performance is only feasible with the use of electronic identification and associated equipment. Currently there's a lot of negativity towards having RFID in sheep flocks, and that's understandable because it's seen as another compliance cost rather than actually what the benefits are actually going to come through to the farmer. Now this is one of the ways in which the farmer can actually then extract some benefit back and make use of that information as a management tool. One of the approaches or one of the principles that we've used here is that targeting anthelmintic treatments to those which are most in need. Now in particular, where we're using chemicals in food producing animals, rather than using them carte blanche, while we still at times need chemicals, it's important that we don't overuse the chemicals and put off the consumers. Now at the moment there's a lot of consumers that are particularly interested in organic foodstuffs, whereas through this approach it's not necessarily organic, but it is being responsible in the way in which those chemicals are used. For each animal they're drafted on the basis of their weight gain since the last time that they were weighed. So the way we determine that weight gain is by taking into account the animal's size, how much feed they've been offered since they were last weighed, and some of the climatic factors as well, to try and take out some of the environmental influences that target live weight gain. That target live weight gain then is calculated out for each individual and then uploaded up into the weigh head. Then the animals are drafted on whether they make that target live weight gain. Those that do return back to pasture, those that don't get drafted off to one side and they subsequently get treated before they move back out onto pasture. What we're trying to capture is those animals that are actually losing performance at the moment as a consequence of parasitism, and therefore the ones that are most likely to respond to drenching. At the time I was working at the Mordaunt Research Institute in Scotland, just out of Edinburgh. At that time, one of the projects we were involved in was the impact of these targeted selective treatment regimes on the development of anthelmintic resistance. Now it became quite clear to us that we can't evaluate the impact until we developed our own regime in which we can identify which animals to treat. We've developed we call it the Happy Factor program. Currently this is a prototype program and it's not something we're looking at a commercial gain for, but merely this program is there to help to identify what a suitable target live weight gain for each individual animal is likely to be. One of the advantages of this sort of approach is we don't have to rely on fecal egg counts. Even though they're widely used, they're notoriously inaccurate when it comes to actually estimating the worm burden of an animal. The level of egg production depends on the species of parasite that are present, depends on the volume of faeces which is being produced by the animal. Even then, we also know that you can have resistant animals or you can have resilient animals. Now, in terms of resilient animals, they're animals which have a high fecal egg count but don't suffer in terms of their own production loss. So, in terms of using fecal egg counts to determine which animals are likely to benefit from being treated, they really are not a particularly useful indicator from that perspective.
This program was made with funding from New Zealand On Air.